Study Section 3. Analysis of dynamic effects of the spending agent. Introduction. In the analysis presented in the last chapter, we found that an increase in government spending or an increase in investment will lead to increase in output. But will output respond immediately to this spending? The answer is simple no. For instance, consumers may not immediately increase spending. Also, firms may want to wait and be sure that the sudden change requires increase in output. Also, if government want to increase spending, analysis of such spending will have to be spelled out in the budget and get the approval of the House before the real spending takes place. In any of these cases, it takes time before spending can affect output. Thus, lack of recognizing time dimension in the behavior of output will lead to getting what exists in reality wrong. In this chapter, we shall learn how firms respond to output and analyze the dynamic of output in response to changes in spending. We shall also touch how econometrics can be used to estimate some important parameters. Distinction between static and dynamic analysis. When firms react to changes in demand instantaneously by adjusting output in proportion to the change in demand, the analysis is static in nature. When firms delay adjustment in production in response to changes in demand, the analysis is dynamic in nature. The reason why firms may not quickly respond to changes in demand is that production schedules are costly to change. Also, recruiting when demand rises and firing when it falls on short notice may be difficult or at best costly. Also, if the change in demand is temporary, it makes no sense for firms to adjust immediately because reversal when the change fails out may not be easy. Given these reasons, we shall assume that it takes time before firms adjust. In our analysis, we shall think of such time as a period sufficient enough for firms to make adjustment. Let us assume it takes 3 months, a quarter. To add time dimension to our analysis, we shall use T. For instance, production at period T will be depicted as YT, while production at the coming year will be depicted as YT minus 1. That is, production that follows that of YT. Also, production at T-1 is depicted as YT-1 and it means production that took place at a period before time T. In most cases, YT-1, also called lagged value of output, in particular, YT-1, YT and YT plus 1 will be outputs at last quarter, current output, and next quarter output respectively. Movement of output when firms delay adjustment in response to change in demand. As discussed earlier, firms usually set production level at the beginning of each period, a quarter in our case. Such production level cannot be adjusted immediately during that period if there is a change in demand. What will the firms do? Instead of changing production, they make use of their inventories to make up the difference. For instance, if demand exceeds production, firms will draw down their inventories and so in that period, inventory will be negative. Conversely, if production exceeds demand, firms will have to build up inventories instead of lay off workers so that inventories will be positive. Thus, during booming period, inventories will be negative, while during recession, inventories will be positive. One important question we need to answer is what determines the level of output firms initially set. The answer is firms set production at the expected sales for that period. How? Assuming that firms note that there is no significant policy change, it is reasonable to set production this period equal to production last period. Thus, if production is depicted as Y and sales is depicted as T, given our assumption, the following equilibrium holds. Equation 3.2 use the fact that amount of sale demand is accounted for by current consumption, investment, and government spending. By the same token, the behavioral characteristics of consumption, investment, and government expenditure at period T are as follows. Thus, at period T, demand becomes. The interpretation of equation 3.6 is similar to equation 2.6. It says that demand depends on income, taxes, investment, and government spending. If we substitute 3.6 into 3.1, we get equation 3.7. That is, next period production depends on current period's production and autonomous spending in the current period. Now, assuming that we wish to follow the output through time, holding exogenous spending constant, what will be the level of output that the economy will settle at equilibrium? This can be obtained by solving for y in equation 3.7. Recall that equilibrium future output is equal to current output, that is, equilibrium output is determined by two terms. First, the size of the multiplier given by 1 over 1 minus b, and second, the exogenous variables. We see that this interpretation is not new. However, the only difference is that the new level given by y is not attained right away, it takes time. We now turn to how the adjustment takes place. Dynamic analysis of government spending. Suppose that in 2009, the level of government spending increased by 5 million naira and remains at the value forever. We shall trace the effect of this change on production in new periods. When we use a model of this type to examine the effect of a change in any of the exogenous variables on the dependent variable, we say we are carrying out a simulation. This output will increase by 3 million naira in the second year. So thus the income. Increase in income will lead to increase in consumption by 1.8 million naira, 0.6 times 3. In the third year, increase in sales to the tune of 1.8 million naira causes firms to increase production by 1.8 million naira, and this will also lead to increase in income to the tune of 1.8 million naira. In the fourth round, 60% of the increase in income will be spent on consumption and sales will increase by 1.08 million naira. In each year, increase in production will lead to an increase in income and this will lead to further increase in consumption, lead to increase in sale, increase in production, increase in income, and increase in consumption, and so on. When this ends, and what will be the total output at the end of the rounds? We will add year-to-year increases. For instance, increase in sales production following the year when government increases spending will be, but 0.6 is the MPC depicted as B. Thus, for n years, the cumulative increase in output will be. The number of years n gets larger and larger. The sum of the geometric series approaches a limit given by 1 over 1 minus b, that is, this implies that the eventual increase in output is given by 1 over 1 minus b. The multiplier, in our own case, the multiplier will be 1 over 1 minus 0.6 is equal to 1 over 0.4. Recall that this multiplier is the same for a change in autonomous consumption. It turns out that multiplier measures the multiple by which income will change for a one and for all change in any of the exogenous variables. The graphical representation of dynamic effect of changes in government spending or exogenous consumption is shown in Figure 3.1. Production in year T is shown on the horizontal axis, while sales demand is shown on the vertical side. At point B, sales demand is higher than production, and so there will be pressure on output to rise. But firms will not increase production immediately. Rather, they reduce their inventories by 5 billion naira, but in the following year. They will update inventories by increasing output by 5 billion naira. Thus, at year T plus 1, YT plus 1 is equal to DT plus 1. The economy would then be at point D, a point that is higher than production level. The economy would then be at point D, a point that is higher than production level. Firms further respond to this high demand in year T plus 2. This increase in sales that leads to increase in production continues until a point such as G is reached. Output eventually increases from Y to YT. Causal relationship between disposable income and consumption. The graphical and algebraic equation shows that there is a positive relationship between disposable income and consumption. It is possible to quantify how strong, reliable this relationship is. The use of correlation method can provide more insight into this. To do this, we collect data on income and consumption over some years, say from 1970 to 2009, and enter the data into the eViews, Excel, or Stata spreadsheet. We then invoke Spearman Production Moment Correlation Coefficient command. The result will be shown. Note that the result given will be interpreted as a relationship. It will not say anything about effect of causality. For instance, if there is a positive strong relationship between disposable income and consumption, it is not clear whether disposable income will cause consumption to change or it is consumption that will cause disposable income to change. Our model, however, gives us a clue to this causation. According to the model, income appears to cause consumption, but consumption also tends to cause income. To examine this causation closely, we adopt econometric method. Note that we collected data for two variables, disposable income and consumption. We need to specify a dependent variable and the independent variable. Going by our model, consumption is the dependent variable while disposable income will be the independent variable. We now specify an econometric model that will examine the effect of disposable income on consumption, such as the A0 represents the intercept A, while A1 is the MPC. The mu captures other unobserved variables such as sex, education, location that affect consumption but not captured in the model. When we run the above model and the t-statistics of A1 is significant, we will be readily sure that truly disposable income causes affect consumption. Although disposable income may affect consumption, it is also possible for consumption to affect disposable income. Indeed, our model shows that consumption causes disposable income because if consumers decide to spend more from their income, then AE will increase, income will increase, output will also increase. It follows that since part of the relationship between consumption and disposable income comes from the effect of consumption on disposable income, Any conclusion based on the fact that disposable income affects consumption will be partially correct. Meanwhile, such variables is not easy to be found. In econometric, we refer to problem of finding appropriate exogenous variable that can explain GDP as the identification problem. And method of estimating a model requiring instrumental variable is called instrumental variable method, IV method. In most cases, we employ the lags of independent variables such as in our own case. Summary: output does not respond immediately to fiscal policy changes because it takes some time before firms change production schedule. As a result, firms set production at the expected sale for that period. The determinant of dynamic equilibrium income is not different from the static one, only that the dynamic equilibrium is time dependent. That is, output adjusts not immediately but with time. Although disposable income determines consumption, consumption can also determine disposable income. If consumption rises, demand will increase and this will lead to increase in disposable income. This implies that there is a correlation versus causality trap in the consumption income nexus. If we adopt the OLS to determine MPC, the coefficient will bias and inefficient because of the causality problem. To deal with this biasness, we look for an instrumental variable. The problem of getting the right instrumental variable is referred to as identification problem.